Late Jurassic North America wasn't just dangerous, it was a pressure cooker of death. The western United States in particular was a savage, unforgiving arena where the land itself seemed designed to kill. Severe dry seasons scorched the earth, water vanished, and the weak were erased without mercy. Only the most formidable creatures on the planet could carve out an existence here. Titanic sauropods that shook the ground with every step, and giant theropods that ruled the land with iron jaws and burning hunger. Among them stalked the infamous Allosaurus, the colossal Torvosaurus, and the nightmarish Saurophaganax. This was the land of giants. But sheer size was never the whole story. Because, as the old saying goes, it's not the size of the dog in the fight, it's the size of the fight in the dog. And no creature in these badlands embodied that more completely than one predator. Compact, relentless, built like a biological weapon. This is the story of the hellhound of the Jurassic, the Ceratosaurus. The Ceratosaurus, like so many of the fearsome predators of the late Jurassic, was unearthed from one of the most legendary fossil sites on Earth, the Morrison Formation, a sweeping sequence of ancient Jurassic rock that stretches beneath 13 US states. The Morrison has given us more dinosaur bones than almost anywhere else on the planet. It was specifically from the Garden Park site in Colorado that the first Ceratosaurus was pulled from the ground in 1883, and from the moment paleontologists laid eyes on it, they knew they had something extraordinary. The specimen was nearly complete. That was almost unheard of at the time, and it meant the description process could move fast. Just 1 year later, the legendary, and sometimes controversial, paleontologist Othniel Charles Marsh formally described and named this new theropod Ceratosaurus, meaning, quite simply, horn lizard, named for the striking nasal horn that immediately set this animal apart from anything else discovered before it. At the time, it was the best-known theropod ever found in America. But Marsh, brilliant as he was, still got it wrong. His reconstruction gave the Ceratosaurus incorrect proportions and a posture we now know was completely off. It wouldn't be the last time early paleontology needed correcting. And thanks to decades of new discoveries and evolving science, we now have a far more accurate and far more terrifying picture of what this animal truly was. So what exactly were we dealing with? The Ceratosaurus was a medium-sized theropod. But don't let that fool you into underestimating it. Size estimates shift depending on which species you're looking at. The type species, Ceratosaurus nasicornis, stretched to around 5.69 meters, roughly 18.7 feet, though certain individuals of that same species potentially reached 6 meters, or 20 feet in length. Then there's a second species, Ceratosaurus dentasulcatus, which pushed the boundaries even further, with one remarkable specimen reaching 7 meters, 23 feet long, and tipping the scales at around 980 kilograms. Nearly 2,100 pounds. That is the weight of a massive American bison. Now, it's worth noting that some paleontologists don't actually accept Dentasulcatus as a separate species at all. Their argument is that these larger individuals were simply Ceratosaurus nasicornis at a more advanced growth stage. Bigger, older, more battle-hardened versions of the same animal. The debate hasn't been settled. But what isn't up for debate is this. Even at its smallest, the Ceratosaurus was no pushover. And even at its largest, it was still smaller than the monsters it shared its world with. That disparity forced the Ceratosaurus to evolve something that would make up for every inch it lacked. The skull. That is where the Ceratosaurus invested everything. Proportionally enormous for its body size, the skull of the Ceratosaurus was engineered for destruction. The front section was robustly built, wide, dense, and powerful, designed to deliver crushing, devastating bites. But the rear of the skull was more lightly constructed, which gave the animal the ability to open its jaws to an almost alarming width. Power in the front, flexibility in the back. The combination made it one of the most versatile killing machines in its ecosystem. and the teeth matched the architecture. Roughly 26 blade-like teeth, each one proportionally large, not just in size, but in robustness. These weren't fragile, thin hunting tools. The serrations along each tooth were uncharacteristically thick and reinforced, built for one specific purpose: tearing. The Ceratosaurus didn't kill clean. It killed brutally, ripping chunks of flesh free, opening massive wounds, and causing catastrophic blood loss in its prey. It was a weapon designed not for a single killing blow, but for relentless, savage attrition. But the skull had one more feature that stopped paleontologists cold the moment they first saw it: the horns. Above each eye, the Ceratosaurus carried two small brow horns, a feature shared with the Allosaurus. But what no one had seen before, and what immediately became this animal's defining trait, was the large, standalone nasal horn rising from directly behind its nose, towering above the others. The bone core alone measured 13 centimeters, over 5 inches, and while alive, that horn would have been sheathed in keratin, the same material as your fingernails, meaning the true size of that horn in life was almost certainly even larger. Early paleontologists assumed it was a weapon, a battering ram for hunting, for defense, for dominance. But modern science has largely walked that back. The current consensus leans toward the horn being primarily a display structure, used for recognition, intimidation, and competition during mating season, though the possibility that it saw some use in direct interspecies confrontation hasn't been ruled out entirely. Beyond the skull, the Ceratosaurus followed the classic theropod blueprint: powerful hind legs built for speed, reduced forelimbs. But those smaller arms, though visually unimpressive, may have still retained genuine grasping function, potentially used to seize and control struggling prey before the jaws did the real work. The legs, though, were the true engine of the hunt. Adapted for rapid acceleration, the Ceratosaurus is thought to have been a stalker, biding its time, reading the terrain, waiting for the right moment, before exploding into motion and closing the gap with terrifying speed. Then the jaws took over. And once those jaws locked on, the outcome was rarely in doubt. But what exactly was it hunting? This question has sparked one of the most heated debates in Ceratosaurus research, and it's still not fully resolved. For a long time, the assumption was simple. It preyed on other dinosaurs: juvenile sauropods, Stegosaurus, the usual suspects. Then, in the early 2000s, everything got more complicated. Researchers began noticing a pattern. Ceratosaurus remains were turning up almost exclusively near ancient water sources: floodplains, lake margins, swamps. Meanwhile, its neighbor and rival, the Allosaurus, was found distributed evenly across both aquatic and terrestrial environments. That asymmetry was hard to ignore. A hypothesis emerged that the Ceratosaurus may have been a semi-aquatic specialist, built not just to wade into water, but to actively hunt within it. Fish, early crocodiles, turtles. The deep, muscular, laterally flattened tail of the Ceratosaurus, strikingly similar to that of a modern crocodilian, only fueled the theory. The idea was bold and deeply polarizing. Most paleontologists pushed back hard. The dominant view today is a middle ground. The Ceratosaurus was fundamentally a terrestrial predator, but one that was more comfortable in and around water than its rivals, and more opportunistic in its diet than previously thought. When aquatic prey was available, it hunted it. When it wasn't, it turned to other dinosaurs. It was a generalist with a flexible strategy, and in the brutal world of the Morrison Formation, that flexibility may have been the key to its survival. Because surviving in the Morrison wasn't just about being a good hunter. It was about being smart enough, or aggressive enough, to carve out your own niche in an ecosystem already packed with apex predators. A landmark 1998 study shed remarkable light on exactly how the Ceratosaurus managed this. Researchers identified two distinct skull morphs within the Allosaurus population, one with a shorter snout, one with a longer snout. and discovered something striking. Ceratosaurus remains were commonly found alongside the short-snouted Allosaurus, but were virtually absent from areas dominated by the long-snouted morph. The interpretation was clear. The long-snouted Allosaurus had a diet close enough to the Ceratosauruses that direct competition between them was intense, forcing the Ceratosaurus out. The short-snouted morph, with its differently shaped skull and likely different prey preferences, competed less directly. So the Ceratosaurus gravitated toward those shared territories, reducing friction and carving out a viable space in a world that gave no animal an easy path. It was ecological strategy. Survival through adaptation, not just aggression. But even the best strategy has its breaking point. The Jurassic could be generous, and it could be absolutely merciless. During the wet seasons, rivers flooded their banks, lakes swelled, and the Morrison exploded with life. Apatosaurus, Brachiosaurus, Camarasaurus, and Diplodocus wandered in enormous herds. Camptosaurus, Dryosaurus, Othniellosaurus, Gargoyleosaurus, and the iconic Stegosaurus grazed across open floodplains. The skies belonged to pterosaurs like Mesodactylus. Rivers teemed with fish, turtles, frogs, salamanders, lizards, and aquatic crocodilomorphs like Amphicoelias. The forest floors were carpeted in mosses, horsetails, cycads, ginkgos, and towering conifers. The Ceratosaurus walked through a living, breathing world between 153 and 148 million years ago that was, in its own brutal way, spectacular. But the dry seasons stripped all of that away. And when they did, the veneer of ecological order collapsed completely. The My Gat Moore Quarry in Colorado stands as one of the starkest records of what happened when resources ran out. Excavations there revealed that a staggering 30% of all dinosaur remains in the area bore theropod bite marks. 30%. At the average fossil site, that number is under 4%. And even more disturbing, after sauropods, it was the theropods themselves that suffered the most bites. Ceratosaurus and Allosaurus were identified as the primary culprits. They were attacking each other, scavenging each other's dead, possibly hunting each other. The ecosystem had gone cannibalistic. Evidence also suggests the Ceratosaurus came into direct violent conflict with even larger theropods during these desperate periods. Torvosaurus and Saurophaganax among them. These were not creatures the Ceratosaurus could overpower on size alone. But the Ceratosaurus wasn't built to overpower. It was built to endure, to fight with everything it had, to refuse to yield. And yet, even the most stubborn survivors eventually meet their end. Around 148 million years ago, the Ceratosaurus, along with the rest of the Morrison dinosaur fauna, disappeared. No one knows precisely what killed it. No single catastrophe has been identified. But given how tightly the Ceratosaurus's existence was bound to the cycle of wet and dry, feast and famine, the most likely answer is that one extended period of brutal, unrelenting environmental stress finally pushed it past the point of no return. The hellhound of the Jurassic had endured for millions of years. It had fought larger animals, outlasted competitors, adapted its diet, carved out its niche, and survived conditions that would have broken lesser creatures. But the Jurassic was not a place that rewarded survival forever. And so the horned lizard, tenacious, ferocious, unforgettable, was finally swallowed by deep time.